Welcome to this lesson on string manipulation and menus. After viewing this lesson, you should be able to determine the number of characters in a string, remove characters from a string, insert characters in a string, align the characters in a string, search a string, combine string functions for dynamic results, access the characters in a string, compare strings using pattern matching, add a menu to a form, and code a menu item's click event procedure.
As we've observed previously, data types in Visual Basic are actually fairly sophisticated objects these days in themselves, and they have a number of very useful methods that we can invoke, and the string is no exception. So if we want to determine the length of a string, we can do so using the length property or the length method to call the length property and determine it. And so all we need is a string expression or something that can be converted into a string expression. And once we've converted it into a string, we have the length method ready for us to call. Okay, so here's some simple code in a form. Here's what the form looks like. I have just a text box and a go button. And then in the click event for that button, I'm declaring a string and initializing it to the value supercalifragilisticexpialidocious, and so that'll be an interesting string of some length. And let's go ahead and put a breakpoint right here, and then we'll look at the watch window to see what the variable properties are, and we'll look at the value of the property of the value of the variable, and also the length property. So let's go ahead and give that a run. And here's our form. And let's put a simple word in here like dog, D-O-G, three characters, and tell it go, and it runs to our breakpoint and then stops. And here I've populated our watch window with my string. And my string is, as we declared it, supercalifragilisticexpialidocious. And here I've set a watch point on my string dot length, and that property returns a value of 34. And here I've taken a look at the text property of the dog. So the text can be interpreted as a string value. And so if I take that string value and add the dot length property to it, it returns a 3. So it's really just that simple. Let's tell this to continue to run, and we'll change that to parrot. P-A-R-R-O-T should give us 6, and we run and we see that indeed that value updates to 6. So pretty simple stuff working with the length property. Very, very useful.
Next, let's look at a couple of other intrinsic functions or methods for manipulating strings on the string data type. And these are commonly used very frequently for routine tasks and cleaning up data or parsing strings that we need to work with. So the first we want to look at is the trim method, and that will remove any spaces from before the string and after the string. So it trims blank spaces from either end of the string. And then we'll look at the remove method, which allows us to pick some point to start removing characters in a string and the number of characters to be removed. So we can remove stuff from the front, the back, or anywhere in the middle of the string using the remove method. Okay, so I've set this up. We have the same form we were working with. We've got a go button and a text box. And what we're doing here, I declare my string, and I get whatever was entered into from the text box and put that into my string. And what we'll do when we enter that is we'll put some spaces either at the front or the back, or in this case both, and see that when we then use the trim method and store that to a new string, my trimmed string will be foreshortened by the leading and trailing blanks. It'll get rid of the spaces for us. So then we've got data we really want to work with. And then we'll do some additional foreshortening. And this is going to remove from the very first character, we start counting at 0, you'll recall. So from the 0 character, it'll remove the first 4, 0, 1, 2, 3 characters from the string and store that into my shortened string. Okay, so let's give that a run. I've already set some variables in the watch window that will give us their values. And I've set a breakpoint at the end of the click events subroutine. And let's run that. Okay, so here's our form. And I'm going to put 5 spaces in here. 1, 2, 3, 4, 5. And then my name, Jon Bek, and then 1, 2, 3, 4, 5 more spaces. So 5 and 5 is 10, 6 letters in my name is 16, and a space in the middle is 17 characters in the whole string. Let's see if that's true. And yes, it is. So, and you can see here that the string has the leading spaces, but when it ran through and created my trimmed string, notice that the leading spaces and the trailing spaces to the Jon Bek string are now shortened, and now we're down to 7 characters in that, Jon space Bek. And then finally, when it removes the first 4 characters, so starting at the Jon space 0, 1, 2, 3, those are the first 4 characters. What it leaves behind is Bek. And so that worked very nicely. Okay, we can combine the uh, uh, the remove function here. If we didn't know exactly where we wanted to start on some particular character, we could put another function within this function to search for a certain set of characters within that string. So we can combine these to make a much more complicated but much more powerful expression. Right now it's hard-coded to start at the beginning and just take the first 4 characters. But we can start to sort of write many little programs right within string functions, functions within functions that we call, and we'll see that coming up. Having seen how to remove characters from a string, let's see the complementary function or the complementary method for the string object, and that would be to insert characters into a string. So I've modified our form again. I have just our text box and our go button. Let's go ahead and resize the form a little bit. And the data I'm going to use as a test entry on this initially in that text box is going to be my name, Jon space Bek. And I put a little counter there at the top here in the comments to show that we start counting the string at 0. So J is in the 0 position, O is in the 1 position, N is in the 2 position, space is in the 3 position, and the 4 position starts my last name, Bek. So if I wanted to insert my little middle name, I'd want to start in the 4 position, okay, which is actually the 5th character in the string is where I want to start replacing. So I use the number 4 because that's the 5th element, 0, 1, 2, 3, 4. Because remember, we start counting at 0. Okay, and let's go ahead and take the text box text and let's replace it with the string created by taking that same text box text and inserting, starting at position 4, LEE, and I want to also include here a trailing space because I want to I don't want it to be Lee Bek. I want it to be Lee space Bek. And let's see how this works. All right. So if I enter my test characters, Jon space Bek, and say go, I get Jon space Lee space Bek as expected. Now, obviously, if I were to do something strange here other than the expected test entry, it's still going to go to the 5th position, enter Lee and a space. So if I were to put in the word elephant, uh, it's going to end up with nonsense. Elif Lee Hunt. Yeah, not quite what we wanted. It really is hard-coded to work with this test entry and only that test entry neatly. And we'll explore a little later how I can change this hard-coded position into, oh, maybe I want to make Lee the middle name for anybody. How can I find where the space is in their name so we know where the middle name should be inserted? We'll learn how to do that. All right. One other thing that let's explore while we're playing with this is this might have surprised you. You might have thought that all we needed to do here is this. Why can't I just say textbot1.text insert for Lee? Well, this is the temporary string. This is the expression. We didn't actually set textbox.1.text to that expression. And let's see what happens because it can be a little bit mystifying to students who haven't encountered this before. If we try that, if you're thinking that's going to change it, and I type in my entry and say go, nothing appears to have happened. Go, 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 go. And that's because we are not changing this. We are looking at an expression here, but this expression, we're not doing anything with it. There's no assignment of it. We're creating the expression and just not putting it anywhere. So what we have to do in order to make that work is we have to not only create the expression, but we need to put it into the text box to update the text box. So that's why that works a little bit different than perhaps you had expected. And again, see that it's working properly now. And go. There we go. Okay. So on to the next experiment. We've seen how to use the trim function to remove leading or trailing blanks from a string. But what if we need to get a string to become a certain length? So we could pad the string with either spaces or a character that we specify. So let's take a look at the pad function. One of the reasons this can be really useful is to get strings to line up in nice columns. And so we might want to pad to a fixed length, and in some cases we'll fill it with spaces. In some cases we might want to fill with a character. So let's take a look. Like if we're doing a check ledger, we'll fill with the asterisk here. So let's take a look at what this code does. So here's our go buttons click event, and we have our string that we are populating from whatever was put into the text box. And just for fun, I've thrown format currency on that. So that string will come up and be formatted as currency. Once we have that currency formatted string, we'd like to set it so that if I put a whole list of the string that we get from the text box into a list box, I'd like them to line up nicely. Okay, so I'm going to use our old friend, the list box items add, to add to a list. And I've added a list box here to our interface. And so we're going to add every time that button is pushed, whatever the string that was entered in our text box, formatted as currency, and then we're going to pad it out to make it a total of 15 characters long. And what we're going to use to pad that from the left-hand side is the asterisk character. So quote asterisk quote NC for character. And let's see what that will do for us. So I've got no breakpoints running. Let's just see the code working. All right, so let's put a number in here like 1, 2, 3, 4, 5, 6.78 and go. And we see that it has indeed been formatted as currency, and then any space left over, if it's not at least 15 characters long, is padded out from the left with the asterisk symbol. Let's shorten up that entry a little bit and see what happens when we do it a second time. So in this case, an additional asterisk was added to make up for the fact that this is a shorter number, and it's padded it out, and notice they still align very nicely. And I can continue that, and it continues to align quite nicely. And so this is what we'd want to have in a ledger, or if I was printing a report or displaying numbers that users would want to look at in total or do something else. You want them to line the columns up as well as the rows. Okay. I've cheated a little bit though. Let's take a look at one other thing that I've done here. You notice that this font is using our usual Windows system font, and this is a different font. And here's the reason why, and that is in Windows, when we talk about fonts, most fonts are what we call proportionally spaced. So in other words, a capital M takes up a lot more space than a lowercase I. Okay, so counting the number of characters would not be a good way to align it. So I've picked a Courier font, which is one of a couple fonts that are not proportionally spaced. They work like a typewriter font. Every character, whether it's a capital M or capital W or a lowercase I or lowercase j, which are the skinnier characters, will take up exactly the same amount of space. They aren't adjusted proportional to how big the character is. Okay, let's take a look at what would have happened if we hadn't made that adjustment. And that gets us into typography, which is really a little more advanced programming issue. One you can certainly learn and deal with, but there are a lot of twists and turns there that we're not going to explore. So if I simply come over to the list box and take a look at the font that was there, and if I switch that back to its default, which was Microsoft Sans Serif 8 1/4 point font. And now if we were to run that again, 1, 2, 3, 4, 5, 6, 7, 8, and go. Okay, so far, so good, at least that's how it looks. Now let's shorten that up a little bit. Notice that we have the same number of characters, but our alignment is not quite the same because the asterisks don't take the same amount of space as these characters do. And I'm not even sure that all the numerals take the same amount of space. So that could be contributory. I'd have to go play with that to determine if that's the case. And again, we definitely have skinnier asterisks because see this moved it over. Even though we've still padded it out to the same number of characters, the alignment is skewing to the left a little bit. Our decimal point is not nicely aligned, and this 8 is a lot further out. Okay, so again, how did I make the math come out right? I turned it to a non-proportional font. And let's go back and reverse that just to see how that worked. So in our list box, I went up to the font and changed that to a Courier font, Courier New, 8 1/4 points. So same size font, but different font face. And this one is non-proportional. And now when we run this, 98765.4.32 and start cutting it down. Now it behaves as we would expect because each character, regardless of that character, takes up the same amount of horizontal space on the screen, and I'm getting nicer results. Okay, we can place some games or functions that will let us read the size, the proportional size of the font, what we call font metrics, and we could certainly do that with, if we needed to, with a proportionally spaced font, but there's a little more work involved, and so this is the quicker and easier way to do that. But the main thing is to learn to pad out these strings, and again, we can easily change the character we use to pad those out. If we wanted to use a different character, we could do so. And there, now we've padded it out with the caret symbol. And for that matter, we could certainly use a space and pad it out with just blank spaces, which is very common for us to do. And that will work nicely as well. All right, so that's how we can pad left. There's a complementary alignment string manipulator, pad right. It works exactly the same way, and so you can use that. Most commonly, we tend to be doing stuff to pad left, but pad right is certainly possible, and you would use whichever method is appropriate to the task at hand. Now let's explore how we search strings for substrings, and we'll look at two indicators there. One of the methods is the contains method, and that tells us true or false whether the string we're searching for is contained by the original string. And then we'll also look at index of. And so if one string is contained by another, we can see at what position that string is found. Okay, so I've set up our form with two text boxes, and I've got a disabled checkbox here. Disabled because I want the program to be able to turn it on and off, but I don't want the user to be able to change it. So making that enabled equals false is the same as making it like a read-only control. And I've got a label that is going to be invisible if it's not contained, but if the text is contained from string 2 or text box 2 is found in text box 1, then we want to turn that label on, and we're going to give a message here in this label that says at what position it's found. So let's go ahead and see this run before we look at the code and get a feel for this. Okay. So here's my form, and I'm going to enter the word mammoth. And then I'm going to say, well, is the word moth found inside mammoth? Go. And it says, yes, it is contained, and it's found at position 3. Let's see if that's true. So 0, 1, 2, and the third position is where we start the M in M-O-T-H. So that is correct. Okay. Notice something important here. If I looked for moth, all caps, and the original string is mammoth, lowercase or mixed case, and I say go, so no, that string's not there, and that's correct because we're looking for a case sensitive match on this, okay? Now, just to show that it'll work anywhere, it doesn't have to be at the very end or the very beginning, let's look for a string that's contained entirely inside the word mammoth. How about ammo? That's a fun word. And go, and it says yes, it is contained, and it's found at position 1. So this is position 0, and then the next is 1, AMMO, there it is. So our code appears to be working correctly. Let's see how this code actually operates then. Okay. So here I've got my form. Just to tidy things up, I've left the label visible at design time, but as soon as the form loads, it hides it. So we start with that label indicator being hidden. It's invisible. And we come in here and we're going to set the checkbox checked state based on whether or not the contains method returns a true or a false. Now remember, this is just a go, no go. It's sort of like an idiot light, as we used to call them on the dashboard of a car. The light lights up, you got some problem with your engine. You don't know what that problem is. We need to take it to a mechanic and find out, but we know that it contains it or doesn't contain it. Just a simple go, no go test. And a lot of times that's all we need for our purposes. We don't really care where in one string another is contained. Now, this is not a string. This is a string expression. So textbox1.text translates to a string type. And then we say dot contain. So this could be any expression that equates to a string, or it could actually be a string variable. Okay, I've sort of, instead of reading the string or the text box text into a string and then testing the string, we're starting to combine more steps, and I'm expecting with your level of experience that you're catching on to that, so it's not too confusing. We could break it down and first, create a string, put the text box 1 text content into a string and then operate on it, but we can combine steps here. There's no reason not to in this case. And textbox1.text contains, and then we look at whatever the textbox2.text is, and this also evaluates as a string expression. So if string expression 2 is found in string expression 1, then contains is going to return a true. So if this is true, if checkbox 1, it's going to check the checkbox. Okay. Then we say, okay, well, if checkbox 1 got checked, then let's take that label and change its text to read at position. And now we need to go look up the actual index of the substring in the first string. So we again take textbox1.text, which evaluates to a string expression, and find the index of, using the index of method, the string expression using the string textbox2.text. So we could put a literal string in here, or we can use anything that evaluates to a string expression. And I'm also casting that to a string because this expression, when I take index of, what is that going to return? That's going to return a numeric, and I want to output it as a string. So I'm adding that, take that number to string, and so we're creating the message for the label at position, colon, space, and whatever the number is that is converted back to a string, 3, 2, 5, whatever it happens to be. Okay. Might have to chew on that a little bit. So again, why do I have to convert this back to a string? Just look at this expression. Index of is going to return an integer value. Okay, so even though I'm operating on a string, I am returning a numeric value, an integer value. So if we find the substring at position 3, we then need to take the number 3, because we want to output it as part of a label, turn it back into a string, and there's our concatenation operator. We're sticking it on to the end of this text at position. So in the example I just cited, 3, at position, colon, space 3 will be the text of our label. And then don't forget, we need to make that label visible. And in all other cases, so if it's not found, we go back to making that label invisible. And that's how our code runs. So now that we have the logic in our mind, let's see it run again. Okay, so potato, and let's see, does it contain pot? And yes, it does at position 0. Does it contain at? Yes, it does at position 3. Does it contain cat? No, does not contain cat. So there we are. Now, if you're thinking ahead, in some of our earlier explorations, we had to hard code, when we were inserting a string, we had to hard code what position you want to insert it at. Now that we can do interesting things like find the index of, we can start replacing that with the value that is dynamically determined, where the index of some substring is found, and we can dynamically manipulate strings. We don't have to know exactly what the string is ahead of time. We can have our program logic do that for us. So we're starting to get into some interesting territory, and we'll explore that before we're done with today's lesson. All right, now let's take a look at how we can start to put all this together to make some really dynamic string functions rather than having to hard code specific values and locations. And you can certainly take this simple example far beyond this. But let me tell you a little story. So I have 4 nieces, and my sister very wisely gave each of them the same middle name. So in their childhood, when she was particularly perturbed with them, she could just shout their middle name, Marie, and they'd all have to come running and then we could start passing out punishments to the guilty parties. So a little discipline in the family there. All right, so let's take a look at how we would go about replacing the space in each of the nieces' names with their middle name, Marie. Okay, so let's run this. And my eldest niece is Lindsay O'Neill. So there's one space in this word, and what we want to do is we want to find the space, and at the index of that space, we want to replace the space with space Marie, and then the space that we displaced will be at the end space O'Neill. So Lindsay space Marie space O'Neill, and there it is. Now Lindsay has a different length name than Christina O'Neill, one of my other nieces. And so it's going to dynamically determine, rather than hard-coded, the space. It's going to go find that space and know that's where we need to put the word O'Neill or Marie. And there's Christina Marie O'Neill. And then my niece Kellyanne, goes by Kelly O'Neill, and definitely a much shorter name, and it still finds the space, puts it in the right place, Kelly Marie O'Neill. And just to make it real clear, if it was Bob Smith, it will still find the space and insert Marie, Bob Marie Smith. So there you are. Let's see how we achieved that bit of dynamic determination as where the substring should be inserted. And here it is in the code. Now, again, I'm expecting you at this point to start to be able to parse complexity for yourself. So all of that is going on in this one line, which really shows the power of combining or nesting these functions together. But it does mean you'll need to develop an eye for parsing this. So let's start with the left-hand side of the assignment operator. What we are replacing is the text box text. Now, what are we replacing it with? Well, there's some expression that obviously at the end of that processing is going to be a string expression, because that's what we put in text box text. But let's see what it is. So let's look for the innermost pair of parentheses. There's the innermost pair of parentheses, and we're doing something with a space. We're looking for the index of the space, and we are looking for the index of the space on textbox1.text. So we find where the space is located. We're going to get the offset, the character number, a location of that. Then what are we doing with that? Well, the rest of this is still nested parentheses. We are doing something with the string Marie at that location, and we come out here, we find we're using the insert method. See how we're reading from the inside out? And we are inserting at the location determined where the space resides. Using the insert method, we're inserting Marie. So first index of finds it, then insert puts something at that location. What it puts there is space Marie, and that is operating on the text box text. And so having formulated a new replacement string, at long last the result gets placed into text box text. So if it is more useful for you as you're learning this to break this down into several steps, you could certainly do so. You can declare a string variable and start working on it piece by piece and make several separate lines. We could break this into 3 or 4 separate lines and do it stepwise. But I also am looking for you at this point in your studies and experience to be able to start to parse some complexity, working from the inside out to see how everything works together. Because obviously some of our string expressions can get quite complex. And this also reminds us of why it would be useful to add a little documentation in the form of comments. You should be developing good habits and doing this as you go. It helps you. It helps anybody looking at your code, which right now means me. So we could say something like, the following code will find the first occurrence of a space in a name, and then replace it, spell replace correctly, with the middle name Marie. Okay. Notice I've intentionally shown the preceding space because we're replacing the space with the space because we don't want the middle name to start right after the last letter of the first name. We need to put that space back in, and then the other space and the surname that we're getting displaced by the insert will show up at the end of it. Okay, so there's some documentation for it. And then now that we understand how the code is running, let's see that in operation again. Okay, so let's see, we didn't do Tracy. So my fourth niece is Tracy O'Neill, and bam, there it is. It found the first space, replaced it with space Marie, and then what was pushed out at the end was what was already there, which is space O'Neill, and there we go. And if we run this again, this is interesting. It's going to find that first space and make it Tracy Marie Marie O'Neill, and Marie 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 O'Neill, and so on. So have fun with that. Now that we've had a chance to explore the contains and index of string functions, let's take a look at doing further work with substrings, different portions of strings, and how we can manipulate them. Okay, so I've modified our form once again, and here is our initial text box, and we're going to put a full first and last name separated by a space in here, and then we're going to, under program control, automatically detect that space and split the first name into this text box and the last name into this text box. So let's see this in action, and then we'll talk about how we achieve that. All right, so here we'll put in a name of one length, my name, badly misspelled, or maybe the way I spell it is badly misspelled, and this is the right way, but anyway, different than the way I spell my name. 4 letters in each name instead of 3. And when we say go, it dynamically scanned through here, found the index which is of the space, which is at this position. So 0, 1, 2, 3, 4 in position 4. So the 5th character is the space. And then it used the substring method to get the first, how many? 1, 2, 3, 4 characters of the string and put them here. And then skipping 1, because we don't want to have the space in front of the last name, it put those in here, BECK. Okay. And if we change this, just to show that it isn't dependent on that space being in that 4th positions or position 4. So now it literally is in the 4th position. 0, 1, 2, 3. It's in the 3 position, which is the 4th character because we start counting at 0. So now when we split it, it automatically splits the first name at the new location of the space and the last name thereafter. And just to show that it isn't catching any extra spaces, leading or trailing in there, then you know that I've done the math correctly. I'm highlighting this, and it shows the whole element that's been added there. So even if our math hadn't been right, one of the ways we could clean it up, if we caught that trailing space by or a leading space, we could have used alternatively in our design the trim function to get rid of leading or trailing spaces, right? So if that already occurred to you, give yourself a gold star. You're thinking on your feet. That's not, however, how I did it. Let's go take a look and see how I chose to do that in this implementation. Okay, so here I have created a separate variable. And if you're clever, you might be able to do it without doing this, but I wanted to do this for clarity. And so I've broken this out. So here's space index. So it's going to be the index value, integer value of where I find the space in a string. And it is declared that variable as an integer. And then I assign that variable to be equal to, and here's our old friend index of, so go find where that space is in this text box.text expression. And again, this can be an actual string variable or any expression that evaluates to a string is acceptable for using the string methods. So we now know what position the space is found. And I said, okay, let's take the uh, text fname box, the text value of that, and let's assign that to be equal to the original text box string substring is the new function we're learning here, the new string method. And we're starting at the beginning and going through the space that is the numeric value of where the space is found. So what we previously identified, count how many in that is, and then that's the number, or that's the character position that we want. So 0 through this. So if it was JON space, so for it's going to go 0, 1, 2, 3. Okay, so 0, 1, 2 characters will be placed into text fname.text. And then for the last name, we're going to do the same thing, only in this case, we are starting at the, not at the 0 position. So notice that this is slightly different. There are two parameters here in this. We start at this position and go this many spaces. So it's that partial substring. This, which has only one value here, it says start at one more than where the space is found. And when you don't specify how many characters to read in the substring after that, it will go to the end of the original string. So this is going from, you could think of it as go from here, to the end of string. Only the way we specify that is not to specify that at all. So that's the default parameter for this version of the method. And so that'll grab that and put that into the last name text box. And bam, we're done. Okay, so let's go ahead and run that again and say William Smith and go. And that works nicely. Now, one of the things that I hope you are noticing and you're thinking about is in my demonstration to exercise these methods, I'm not putting a lot of robust error handling. And if you think about it, there are some ways we could mess this up. So for instance, what would happen if you had a name like Sarah Mac space Donald? Which space is it supposed to use? Well, in this case, it works out happily because it takes the first space, but that doesn't have to be the case. So let's say someone treats their first name Mary K. Smith, and we intend that she's, or Mary Kate Smith. Okay. Mary Kate is what all her friends call her as a first name. It's not hyphenated. It really does have a space between it. So that's one place where our logic kind of falls down. It's treating her last name as Kate Smith. So we would need some more sophisticated parsing to deal with those kind of situations, or some kind of human intervention or rules-based something. Okay. But what about the situation where you have absolutely no space in here, and my code doesn't accommodate for there not being any space? So let's say that I just put in my whole name, no spaces, what does it do with that? Well, it crashed because we didn't trap against that. So we should be doing different error checking to make sure that the algorithm can be applied. So one of the things we might have done is we might have put an if then else and said, hey, you know, if the space is not found in here at all, if the index of it can't be returned, then stop. Don't go any further because we're going to crash the program. Maybe bring up a message box and tell the user that there's a problem. So I'm not taking the time to put all of the error trapping and error checking in here in the demos. Once you get into writing your programs, you're going to need to think more critically about how you would accommodate that kind of flexibility in the program to make sure that the data is validated and can be converted. Something equivalent to try-parse, and we will see more about error trapping and validation in later lessons, but I wanted to get you thinking about that now. All right, so this is our new friend Substring in two versions. One which has the start position we want to find it through the end position, and that doesn't have to be 0. This could be any portion of a string for any length. And then there's also the default that goes from this space to the end, right? So we could also turn it around and go, from the beginning to just an end space. That's really what we've done here. But here we don't have to specify through the end because however long the string is, it knows that's how far we're going. And again, the reason we added 1 was this one gives us everything up to the space, and by adding 1 here, this starts just after the space and goes through the end of the original string. All right, let's leave that there for now. It's time to have some fun with regular expressions and wildcard operators using the like comparison keyword. And we'll show you the code shortly. You may already be familiar with this if you are used to working with regular expressions or with wildcard operators in databases or spreadsheets or several other areas where they're quite commonly used in information systems. Okay, so here is how I redefined or redesigned our form. We have a text box in which to enter a string, and then we have a disabled checkbox we're just using as an indicator if a pattern match is detected. If we look for a wildcard that is matched or pattern that is matched, regular expression that finds a match in our original string, then this will go ahead and become checked. And here's where we can enter the regular expression or the pattern that we want to test for. So let's go ahead and run and see this in action. Okay, so let's start by saying I want to find a match on capital B, any single character LL. Okay, and let's put in the word ball, all caps, and test. And yep, that's a match. What about BULL, all caps? Yep, that's a match. What about if I make it a lowercase u? Is that still a match? Yeah, any character match there, although it can be any case where that wildcard is, but what if I were to make the final L lowercase? No, that's not a match. That has to be a match for case. Now we could overcome that by taking and shifting this whole thing to uppercase or lowercase, this string, beforehand if we wanted to. So that would probably be how we would deal with that. But let's take a look at some other expressions. So let's say I'm doing two-state abbreviations and I want to find out if the entry matches K star, like Kansas or Kentucky. Um, uh, and so how about if it is KS and test, and yep, that's a match. How about KY? Yep, that's a match. What about, what if it was in lowercase? Yeah, that's a match. And again, if I didn't cast it to uppercase or lowercase, and match for upper or lowercase in my pattern, if it doesn't match the static part of the pattern, it's going to fail. And of course, if it's something completely out to lunch, Arizona, and we're looking for K star, that's not going to match. So now I've been testing these on 2 characters, which we usually use for the state, but the asterisk wildcard here is any number of characters, so it could actually be the whole state spelled out, and that would match. And as for that matter, as long as the K is uppercase, if the rest of it is lowercase, that will match. So that's how that wildcard works. Let's do another one. We can get kind of sophisticated in here in looking for our patterns. So let's say that I'm testing. I want to make sure data has been entered correctly, and we have a part numbering system that requires a digit. Oh, let's put it down in the pattern. A digit, and then it can have any number of alpha or numeric characters that follow. So would that match for 1, 2, 3 screwdriver? And test. And yes, 1, 2, 3 screwdriver matches. What about if I have a 1A3 screwdriver? Now, that's not valid according to our rules for validating how we do our part numbering system. This has to be a number. Any 3 numbers will work, and followed by anything. What if, would this work? What if I had 193 followed by no characters? Does that work? Yeah, that works too, because any number of characters, 0 is a number, so 0 would work as well. 0 characters. Okay, or I could have several characters after. That still works. Okay. All right, now let's take a look at a little more sophisticated regular expression. So what if I would like to find any characters, let's say it starts with capital T, and then I don't remember if the name I'm searching for was Tom, T-O-M, or Tim, T-I-M. So if I put this in square brackets, and now I say, is Tim a match? Well, yes, it is. Is Tom a match? Yes, it is. Well, what about Tam? No, Tam is not, because it's not an O or an I. Clever, eh? And we can build some very sophisticated regular expressions here for what kinds of combinations of letters we want. So if we wanted to look for, let's say I want to have a vowel in here. So it can be A, E, I, O, U, and I'm looking for a 4-letter word, and it has to be A, E, I, OU. This would be great for word searches, wouldn't it? So we have, and I've kind of scrolled off the screen here. Need to enlarge the size of the pattern text box, but we can kind of scroll, and you can see it's T followed by any of the usual vowels. I've left out Y and W. And so what would that match? What about T-E-A-M? Does team match? It does. What about tram? Now, R is not a vowel. That shouldn't match. Let's see. No, it doesn't match. Okay. But if I were to say it's teeming, so T-E-E-M, T-E-E-M, so like the waters teem with life. Yeah, that matches. So that's working pretty well. Fun stuff, kind of sophisticated. All right, let's elaborate on this. So let's say that I would like to have any single letter in the range from A to Z, but not more than 1 letter. Okay, so test, this should fail. That fails. Okay, what if I have a single A? that works. B, that works. X works. Y works. Z works. But just to show it's not happy with any single character, 1 doesn't work. Also, AA does not work. Okay. And also lowercase does not work. So I need to change my testing there. So could I make it so that it accepts upper or lowercase without having to shift the string to upper or lower to compare? Well, sure. How about if I make it A through Z? So it's A through Z and A through Z, anything in this range. Does that work? Well, yeah, now the lowercase stuff works. Okay. So, and we can get kind of zany here. So let's say I wanted, it can be an uppercase A through L, but it needs to be a lowercase m through Z. Um, and so since C is not in the uppercase range, but uppercase C would work. What about an M? Uppercase M does not work, but a lowercase m works. And again, just satisfying the first one, if we have, this is looking for a single character in this range. And so if there are extra characters, it doesn't match. So kind of neat. Now, what if I would like to say, gosh, I want it not to be in the range. So here's a range. Let's just take and shorten this one up. So there's the range of lowercase letters M through Z. I could, you know, say give me all A through uppercase A through Z, and I could have, you know, all, uh, all uppercase letters and all numbers and, well, gosh, rather than trying to specify all the inclusions, if the only thing I want to exclude is M through Z, how about I just put a not in there, exclamation mark. And so now, a single character not in the range M through Z. So if it's M, that fails. What if it is lowercase a? That's okay. What if it's number 9? Yeah, that's okay because it's not a lowercase letter in that range. So what if it's a semicolon? Does that work? Yeah, that's okay. So only lowercase m. What about uppercase Z? Okay, why did we get a pattern match there? Oh, because it's not lowercase m through z. What about lowercase z? Ah, that doesn't match because we said exclude m through z. Okay, so nifty. We can combine these expressions to make some very powerful formatting rules and data validation rules, and that's why we do a lot of encoding and formatting on things like part numbers and stock numbers and those kind of things. Let's see. What if we're looking for, I just want to know that somewhere in my string there is a period. Okay, so it can be any length at the beginning, a period, and any length at the end, and that matches. Okay, but what if it's any length at the beginning, a comma, and any length at the end? Well, that doesn't match. Well, what if it's nothing at the beginning? Well, nothing means 0 characters, and the wildcard, the asterisk, says any number, so this should work. 0 characters, then a period, and then any number of characters. Well, yeah, it likes that just fine. What about if I have the characters first and then the period, but nothing after it? Well, yeah, because asterisk can mean 0 as well as many, and we tested it likes that just fine, but if you get rid of that period, it's not happy. What if there are 2 periods? There's nothing here that says I can't have 2 periods, so that's fine. What if I have a period over here too? Again, nothing says I can't. As long as there's a period somewhere in there, it's going to be happy with it. So interesting. Okay, so let's take a look at another part number example. Let's say I would like to have, it's got to have one single letter, A through Z, and then it has to have a second letter, A through Z, in the part number, and then it must have exactly two digits after that. So it's got to look like that. So AA99 kind of pattern. And let's put this in. So if I have XY324, fails because I have too many digits. What about XY32? That passes. What if I turn it around? 32XY. No, that's not going to match the pattern the way I've specified it because I have to have two letters followed by two digits. Okay, any two, and they're uppercase letters? Sure. So we could have ZZ and then 88, and that should satisfy it. Great. What if I do something zany like throw in a period? Well, that doesn't match our pattern, and so that one fails. So there we go. I invite you to explore and play with regular expressions and wildcards further on your own. There's all kinds of powerful combinations we can play with and nifty, nifty things you can do. Regular expressions, if you master them, are enormously powerful. But let's see the exact code we got into to do that. So let's end our run and come over and look at our code. All that power, and look, I got 2 lines of code in the whole program, right? Um, so the first thing I'm doing is I'm setting the checkbox false every time you press the test button, and then or the go button, and then it is simply saying here, hey, um, take this expression, text box one dot text, which evaluates to a string. So this could be any string expression, and I say like text pattern dot text. So that's the second text box. I'm just taking these two string expressions, and I'm saying is the first like the second. Okay, is this string like this pattern? And if it is, that then this whole thing here evaluates to true. And when check CB match checkbox checked is set to true, then the check turns on, and otherwise it's false. So setting it to false means the check is false. Really elegant, a great economy of logic. There are a great economy of code to do all that powerful stuff. You don't have to set it directly. You could set a variable equal, Boolean variable equal to this is true or false. So we could have come up here and done something like dim my bool as Boolean, and then we could have come down here and done it this way. We could have said my bool equals these things, and then we could have said, boy, if we really wanted to make it more complex than it needs to be, we could have said if my bool equals true, then, and we'd have the true part. So we would say text, oh no, so that CB match dot checked equals true. And then we come down here and have else. We would say CB match dot checked equals false. All that extra code does exactly what the code originally did. So you could play with that, but why not just recognize the real economy of code? And here's why. Okay, fewer lines of code to express the identical logic is always going to result in better quality software. The reason is this. Every programmer has some error rate. Let's say you're a really pro programmer and you only make one error in 10,000 lines of code. Well, gosh, if you can do in 10,000 lines of code what takes somebody 10 times more code, 100,000 lines of code, and they have exactly the same error rate, they're going to write the same program and have 10 errors while you fix one error and you then have a flawless program. So Kind of when you think of it that way, you can see that concise code is not only elegant, it is also more likely to be higher quality. The one exception I would say that applies here is sometimes you can be so um, compact in your code that it can be difficult to understand the logic. So um, all things being equal, expand your code a little bit or add comments, please, to make it clearer what your code logic is doing, how it is achieving it, rather than having this marvelous complexity that takes you an extra half hour to figure out what you were doing when you have to maintain the code. So let's go ahead and put this back. We're done with, let's see, these parentheses are, for emphasis, they're fine. They work correctly, but they're not really needed. And now we're back to the bare elegance of two really clean lines of code that make this whole program run. Let's make sure we return it to a working state. And let's take a look for the word anything, followed by done with anything. Am I done? Question mark. Test it. Ha! And I'm not getting a pattern match. What did I do wrong? I done? Ah, let's go find the bug. Okay. Oh, we don't need this. And aha, we stopped using my bool. So let's go ahead and say directly cb match dot checked equals that. And there's our pattern match. I think we've got it correct now. It compiles okay. Let's look for anything, done anything. I think I'm really done now. And am I? Yes, it says I am. So let's end the video here. Let's learn how to add menus to a form. I have a form project open here, and let's name this form, or at least have the text displayed, call it menu demo, just for fun. Okay, and the first thing we need to do is go into our toolbox and find the MenuStrip control and add that. And then let's say that we want to have a file menu, and let's make the accelerator key for that F, file. So use the ampersand FILE. And let's also have a menu to the right of that, and that'll be the help menu, and we'll make the accelerator key for that H, ELP. And then let's see here, under file, let's have open, save, and save as. So Alt O for open, or ampersand O, open. And then ampersand S for save. And then for our save as, since we've already used in that level of the menu the S key as an accelerator, we can't use the same accelerator at the same level, but we can use the same accelerator key under different sub-levels. So if we had a one under the help system, because we're going to go ampersand H ampersand whatever, it's going to be different than ampersand F ampersand whatever. So let's add our save as, and we'll do this one with ampersand A. So save as. Great. And in our help, let's have, how about we'll have documentation, and that could be ampersand documentation. And then here's where we'll reuse an A. So ampersand about. And notice that even though I have Alt F A to go to file save as, Alt H A is different. So I can still have at a different level this the same key, the A key reused. Okay, So that's looking pretty good and pretty easy to do so far. Let's just run this and see what we get. All right, so I get a form and I can click on File and there's Open, File, Save As, and none of those submenus are doing anything because we haven't coded the click event for them yet. Help, Documentation, Help, About, and that all seems to be working, but what about my accelerator keys? Now, right now in my view, in my system setting, accelerator keys don't show until I hold the Alt key, and then I can press the F, and if I press A, I get Save As, and if I say Alt H and continue to hold the Alt key down and say A, then I would get the About. So nifty, the menus are ready to go there. All I need to do is, in the next lesson, code up the click event and we'll make things happen. All right, so now that we've got our menu built, it's time to code up the click event for one of these. And let's do this. Let's click in and we'll code the about box for the um, menu demo program. So if I double click here, it'll take me to the code view and it's gotten the about tool strip menu item click event. It's what we're wiring up. And let's go ahead and put in a um, message box. Oh, is it the about? That's right. Let's go ahead and put in a message box for that. And you've done message boxes before, so I won't belabor the point. I'll just go ahead and paste in some code. And let's go ahead and see what that's going to do for us. So a little more screen real estate here. There we go. So the message box, and the message it's going to give us is, you are running version 1.0 of the menu demo application. Please try to contain your excitement. And then the message box style is it's only going to have an OK button, no cancel, no anything else. And we're going to call that message box about menu demo. And that's really all that the click event here is going to do, is deliver that message box. So let's save it. And let's run it. And so there we are. And if I go to help and about, there's my about box, about menu demo. You're running version 1.0 of the menu demo application. Please try to contain your excitement. Only thing I can do there is OK to dismiss it. And we're there. We can also get there through Alt H, holding the Alt key down, and Alt A, and navigate to it that way rather than through the mouse. And it's all completely satisfactory, and that's really about all there is to it. Other than that, you would go ahead, if you were going to do something more or different in the logic of the click event for a given menu item, you would go ahead and add your additional code to implement it. This concludes the lesson.